So we're going to start out by talking about compounds. And I would say that this is where Unit 5 begins. It's the start of Unit 5. Now going into this, we know something from the previous unit that we want to carry into this unit, and that is that all elements, all atoms want how many valence electrons? Okay, so elements want 8 valence electrons. Right. But do elements naturally have 8? No, a majority of them actually have less than 8. So we could write down that most elements do not naturally have 8 valence electrons. What this means is that they're going to have to do something to fix this problem. And what they are going to do is these elements will chemically react and they'll form bonds. Elements will chemically react and form bonds. Now there's two different ways that this can go. So when we look at bonds, I think we could understand that there are going to be two different types of bonds. Two different ways that this could possibly end up for most atoms. Bonds could either be ionic, or bonds could be covalent. Let's go through some properties of each. Bonds that are covalent involve a sharing of electrons. So electrons are shared between elements. But in the case of ionic compounds, electrons are given and taken. So you can see that there's kind of a difference between them. Ionic bonds are going to be giving and taking electrons, and covalent is going to be sharing electrons. Good? Yep. Ionic bonds are always made of metals and nonmetals bonded together. If you think about it, metals are usually positive or negative in charge. So another way of viewing this is that you have cations bonding with anions. Remember, cations are positive or negative? Very good. Anions are negative. Metals are usually cations. Covalent involves the sharing of electrons. We've already mentioned that. And it is between only nonmetals. Between only nonmetals. Cool? I want to draw out an example of how this looks. NaCl is a good example of an ionic compound. What happens is the Na has how many valence electrons? 1, because it's in the first column. How many valence electrons does the chlorine have? How do you know that? Okay. So it's got 7 valence electrons because it's in the 7 column. What is going to happen here is the metal, sodium, is likely to give up its electron to the chlorine. Remember, metals become cations, right? Which means they become positively charged ions. You see the arrow I've drawn? Now, what's the charge of the Na? Very good, +1. And what's the charge of the Cl? Very good. Writing this out, you have seen what really happens. The Na is plus, the Cl is minus, because it has gained an electron. Do you see that event of giving and taking of electrons? Raise your hand if you see the giving and taking of electrons. The Na is giving, the Cl minus, the Cl is taking. That's why Na becomes positive. That's why Cl becomes negative. Do you understand that event? Let me show you an example of a covalent bond. I'll show you how this works. This is a pretty simple one. Chlorine gas. How many valence electrons does each chlorine have? 7. Is this drawing correct? Does each chlorine have 7 around it? Here's the covalent bond. Did we all catch that? Do you see how the Cl on the right hand side, it has its own 6, but do you see how it's sharing these two right there? So how many valence electrons would you suspect this chlorine seemingly has? Looks like it has 8, right? Look at the chlorine on the right hand side. It only has 6 of its own, then 7, but it's sharing that right there, so that's actually 8 too. This is not a giving and taking event, this is a sharing event. You see the differences between ionic versus covalent now. Jason, what do you think? Very good. Those, and then answer it. Question is, how do you tell an ionic compound from a covalent compound? You can write that down real quick and solve it.